Hey everybody, Miss Teacher here. We're taking a look at question number 9 on the L31. By how many times does the volume of a rectangular prism increase when two of its dimensions are tripled? Now what makes this question a little tricky and different from some of the things that we talked about in class is that we're not doing all of the dimensions, just choosing two of them. So this idea of cubing the value and coming up with one of these numbers might not work. So let's look at our hypothetical example. So let's say our rectangular prism is a 3 by 4 times 2. And if we went ahead and we found the volume of that, we would get 24. If we tripled two of the dimensions, so let's say we tripled this and got 9, and tripled this and got 6. See, here's our new prism. But this remains the same. If we went ahead and found the volume of the new figure, we get 216. So the question is basically asking us how many times bigger is this than this? We're trying to find that out. On a calculator, when you're trying to find this number, we have to apply inverse operations. If we take this number and divide it by this number, we should get how many times bigger this is than the green number. Let's pump them into the calculator. 216 divided by 24, and we get 9. Now, let's talk about, that matches choice C, by the way. Let's talk about the idea of, because we're only affecting two of the dimensions, then we're really only affecting the area. So that would be two-dimensional, right? So if we square this idea of tripling, right, then wouldn't 3 squared be 9? Now ask yourself, would that work every time? And we have this tool here, so let's use a different, let's do a 1 by, how about 2 by 3? 1 by 2 by 3. All right, so here it is, a little small, but let's say we're going to triple. By the way, the volume of that right now, see they give it to you, is 6, and the surface area, but we're not talking about that, is 22. Now let's say we're going to triple this. So if I triple that, that means we're doing 1 times 3, which would be 3. And let's triple this one. 2 times 3 would be 6. So let's make that 6 and leave this one the same. Now recall that the original one had a volume of 6 cubic units. This one has 54. So 6 times what equals 54? It's 9. Since we only dealt with two dimensions, we'd square that value of how many times bigger we made the dimensions, which was by 3, and we would get 9 times bigger. Now if the question was we're doing that to all of them, we're tripling all of the dimensions, so this is the one that we didn't triple. If I triple that, then you're talking about some of the values that we talked about in class. Let's go back to that chart. This chart right here shows the scale factor of the volume when you're dealing with increasing all of the dimensions. But when you're only increasing one of the dimensions or two of the dimensions, then you have to be very careful, and I would think about hypothetical examples. And by the way, we could have chosen any rectangular prism and chosen two of the dimensions, and we'd still find that times 9 thing going on regardless of the dimensions that we chose. And if you don't believe me, try out this app. It's called Surface Area and Volume. You can find it on my Route 66ers webpage, and it's a lot of fun to play with. All right, hopefully you understand this concept a little bit better.